All right, so today we're going to talk about an exponential function with all the bells and whistles. It's going to have a dilation. It's going to have our base. So this right here, the 2 to the x, that's what's going to dictate our table. And then what we're going to be doing to our table, to our graph, is that we're going to multiply all the y's by 2. We're going to set this equal to 0. And then whatever it says, we're going to do it to the x's. So if I were to take x minus 1, set it equal to 0, add 1. So my x value is being increased by a positive 1. And then the vertical shift we just do as is, so I'm going to add 4 to all the y's. So we have two options. Option 1 is building out the table. So what you'll see right here in the middle is if I just had y equals 2 to the x, I would plug in -2, -1, 0, 1, and 2. And 2 squared is 4. 2 to the first is 2, 2 to the 0 is 1, 2 to the -1 is 1/2, and 2 to the -2 is 1/4. And then I'm going to do everything that my dilation and my shifts tell me to do. So first, I am going to go from left to right. So this says whatever my function is, I'm going to multiply it by 2. So I multiplied my outputs all by 2. So 1/4 times 2 is 1/2, 1/2 times 2 is 1, etc. Then this says that I'm moving to the right 1 unit, or adding 1. So I went through and I added 1 to all my x values, -1, 0, 1, 2, 3. And then lastly it says add 4 to the y's, so I added 4 to each of those y values. And that gave me this table right here. And what we're going to find is we're going to have an exponential function that is going to be very steep and is going to be shifted over 1 unit and up 4. So we're going to look something like that is what this function would look like, roughly. That's one way to do it. It's very logical. It goes step by step. You just follow what your shifts say. Now, some people just wanted to plug in. So what you'd want to do to plug in is first think about what we usually want to use. So normally I want to use -2, -1, 0, 1, and 2. But since it shifts everything to the right 1 unit, I'm going to add 1 to every value, which gives me these, and now you simply just plug in these 5 values into your equation. So you'll notice that these x values are the same x values I ended up over here. This took 3 steps. This one will take 2. You adjust by your horizontal shift, and then you plug in each value. It's up to you what you think is easier. I don't care which way you do it. Personally, I think that this way is a little easier because I can see the work and it's just 1 step at a time, whereas this one takes a little bit more because you have to do that 1 step and then you're plugging -1 in here. You're like, all right, 2 to the -2, that's 1/4, times 2, that's 1/2, plus 4, that's 4.5. So you get to the same outcome. It's just a little bit more to do in your head. Your choice. And the 3 graphs that we'll do today, the first one up here is y equals. This is a 3 to the x function that has a dilation of 2, a horizontal shift up here, and a vertical shift there. This one here is a base of 2. There's the exponent, the dilation, the vertical shift. And this one again has a, you know what, let's change this. We're going to make it 1/2 times 1/2. There you go. Make it a little more challenging. So try those 3, see how they go.